We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus in which we are pursuing discuss. Okay, pseudo multivariate calculus. Pseudo multivariate calculus means we write our mathematical formula in multiplication, addition, subtraction, and multiplication, addition, subtraction, and division. And then later, we feel that I can use calculus. When should I feel that I should use calculus rather, and how I can use calculus? So that is the discussion that we are pursuing under a topic pseudo multivariate calculus. Now, anyway, okay, I have a battery in my hand. This is a small battery. This is a lithium ion battery 3.7 volt. And I have a capacitor and RC circuit. One resistor is connected to it. I believe it is 300 ohm. That's it. So it is 300 ohm. And then I have a LED. There is one LED that will glow. Okay, so that is the concept. Okay, so I'm going to charge this kind of. I'll put this capacitor across this battery, and I'll see if it is charged. So the positive should go to positive. Okay, and negative should go to negative. Now I'm going to charge this. Okay, so I am charging this. Now it will be charged. Battery and capacitor I have connected in parallel series, same thing here. Okay, I believe it is charged. Now I am going to put this RC circuit, this is capacitor and this is resistor across this LED. So idea is that LED should glow. Okay, I'll put positive, the positive and negative towards negative. Okay, so this is LED. Now I am going to touch it and it should glow. Okay, so it grew and then it faded. Okay, if I'll do one more time. So idea is that I have to charge this capacitor. Okay, so I'm charging this capacitor with the battery. Okay, I believe it is charged. Now if I place this capacitor across this LED should glow. So I'm going to touch it. Okay, it glue and then it started fading. Okay, the concept is this battery has a energy. Battery has energy, and then that energy is getting stored in a capacitor. When energy is stored in the capacitor, and then I place a, a when I place a kind of resistor LED, if I place this RC circuit along LED, then idea is there is no energy that is spent on the energy. No energy is consumed by the LED. All the energy is consumed by the resistor. So this this is capacitor. This is capacitor, and here there is one small resistance is there. There is one resistance here. If I connect LED here, then capacitor resistance is short circuited, more or less, and energy is consumed by the energy is liberated through the resistor. Anyway, that is the concept. Now, idea is that how much energy this capacitor is storing. That is, energy is like rupee, energy is like dollar, energy is like N. I'm sorry, energy is like yuan. I have to add yuan nowadays because the way China has showed its power, then yuan we have to discuss now. So energy is like I have yuan, I have rupees, I have a ruble, I have pound, I have kind of a euro, I have dollar. That is energy. How much energy you have, how much money you are carrying. That is called energy. Now, if I connect this capacitor across a resistor, then energy is stored in the capacitor through the battery, and that energy is liberated through the through the resistor. Means energy is spent. Money we spend money. So energy is spent on the resistor. So that is the idea. Like if I go to the market and I purchase something, I am spending money. Similarly, the capacitor is spending its energy on the resistor. Okay, the question is arising that how much energy capacitor stores. Okay, how you will find that how much energy capacitor stores. Anyway, one thing. Second thing is that there is something called power. Power means per second or per unit time, how much energy is that energy source is liberating. Okay, per hour, how much joule of energy one energy source has liberated. Like if I have money, then per hour, how much thousands of rupee or hundreds of rupee or rupee per hour I am spending. That is called power. How much money I have? I have 10,000 rupees. Okay, then my energy is 10,000. But if I am spending every hour 10 rupees, then my power is 10. Power is in every hour how much I am spending. That is called power. And then how much I carry, that much is the energy. So in my wallet, if I have anyway, I don't carry any wallet, but in my wallet, if I have 10,000 rupees, then my energy is 10,000. I am walking with 10,000 in my pocket if I have 10,000 rupees. Okay, and then every hour I am spending 10 rupees. My power is 10, but there is another guy. He has whatever money he is carrying, doesn't matter. Every hour he is spending 100 rupees. His power is 100. So power is how much energy someone is spending per hour. Generally, it is written in a bulb 100 watt hour. Every hour 100 joule of energy that bulb is spending. Okay, in the resistance, the tungsten coil is liberating that much energy. It is consuming that much energy, whatever. Okay, now concept is can I find this energy equation for the capacitor? How what is the specification? Capacitor, the voltage across the capacitor plate, the voltage across the capacitor plate, it starts growing if I put it across a battery. Make sense? There is a capacitor. If this is a battery, it's a very powerful battery, though it looks like a small. This is a small 3.7 volt lithium ion battery. If I am connecting this battery across this capacitor starts charging. Okay, what is charge? Charge means capacitor has plate. One is cathode plate and anode plate. Anode plate is positive plate and cathode plate is negative plate. At any moment, how much is the charge that is stored at the plate? That is called how much is the charge. Now, or how much is the voltage that is generated across the plate. That is one measurement of the capacitor energy. Okay, consider that any moment there is a charge that is stored on the plate is Q. Then what is voltage across the plate? Voltage across the plate is Q by C. C is the capacitance of the capacitor. Anyway, we had shown the resistance model of the capacitor also when capacitor is charging, because when capacitor is charging in RC circuit through a battery, capacitor behave like a variable resistor, where beginning there is no resistance of the capacitor, but as we proceed, resistance across the capacitor start growing. Anyway, We are not talking about the resistance model of the capacitor. Rather, we are talking about the capacitor when it is charged from the battery. Now, capacitor is roaming in the air, floating in the air on its own. How much is the wealth of the capacitor? Means how much energy it has stored. Someone can measure the voltage across the capacitor and he can find out what is the wealth of the capacitor. Or someone can find the charge across the plate and he can find what is the wealth of the capacitor. How much joule of energy that capacitor is carrying. Makes sense? Okay. Oh, what are you saying? I'll keep this battery connected to the capacitor and the wealth of this capacitor will keep growing then. Okay, no. The capacitor maximum voltage that it will carry is the battery voltage. That's it. Beyond that, it will not go and it will not carry. Capacitor is not like a human. Okay, there is a difference between capacitor and a human. What is difference between capacitor and a human is whatever money you give to a human, he will keep absorbing the money. Okay, he will never say thank you very much, this is enough for me. Okay, he will keep taking it, whereas capacitor will not keep taking it. After some time it will say it is enough for me. Even if you charge me, I won't take your voltage or charge, whatever it is. But from zero voltage to the maximum voltage that it can keep as per the battery charge. What is the power of the battery? Okay, in that sense, how much voltage it carry. In between, if I have a voltage, consider this battery is 3.7 volt. So if I connect across the RC circuit, capacitor will start charging and its voltage will start from 0 volt and it will go up to 3.7 volt. If it in between, then what is the energy of the capacitor? Anyway, now first we see what is the power of a capacitor. Power of a capacitor is voltage into current. If I am charging this capacitor through a battery, then current is flowing through the capacitor. How I okay, the question is at any moment when voltage is V or any moment when charge is Q, then what is the energy that capacitor is storing? That is the question. Voltage equal to 1 by C into Q. Okay, if Q is more, then voltage will be more. If capacitance is more at the same Q, if I keep growing capacitance, keep the capacitance constant and keep growing the Q, you will get more voltage. Keep the Q constant and keep growing the capacitance, voltage will start decreasing. Okay, but anyway, what is the relationship that we will see now? Okay, now what is the how we can find the energy fundamental? If I talk about the energy fundamental of the capacitor, then power of the capacitor, if I current is flowing through the capacitor and voltage of capacitor is V, then capacitor is sucking power, that is voltage into current, or in capacitor and current, capacitor and resistance model, when capacitor is releasing the current and at any moment the current that is coming out of the capacitor is I and voltage across the plate is V, then V into I, power is being released from the capacitor. Anyway, now the power is, this is our, I have not seen the book that how they calculate the energy stored in the capacitor. So power in the capacitor is voltage into I, and I is charged by time. Whatever is the, how much per unit of time charge is being stored on the capacitor, that is the current, that is in charging circuit. In discharging circuit, per unit of the time or per second, how much charge is being dissipated from the plate, that is the current it is liberating. How much is the charge that it is storing per unit of time, that is the current, or how much is the charge it is releasing per unit of the time, that is the current. Okay, any fact. Now Q by T is the current. Q by T, division means per unit time, Q by T, per unit time, how much Q is either getting stored or how much Q is being liberated, Q by T. Now power is voltage into Q by T. Okay, energy is power is energy by time. Means voltage into charge is the current, is the energy. Makes sense? The power that is any device, how much a resistor is dissipating the power. That is voltage that is across the resistor and current that is flowing through the resistor. Voltage into current, that much power the resistor at that moment it is dissipating. It is eating. Same thing with capacitor also. Voltage into current. Current is charged by time. Now, what this is power? Power is energy by time, and power is voltage into charge by time as per the capacitor. Means voltage into charge is the net energy it is storing. What is the voltage across the plate at a moment and what is the charge across the plate if you multiply, then that is the net wealth of energy that capacitor is carrying right now. If I divide by T, then that is the net power that it is releasing or absorbing. We are talking about energy. So voltage into charge. Where is voltage is a function over charge, where voltage equal to 1 by C into Q. Voltage, no, there is a multiplication. Voltage into charge is the energy that is storing. More you grow in the charge, more energy at that moment it is storing. Makes sense? So voltage into charge Q is the net energy. Now it is multiplication of two items, voltage and charge. Multiplication of any two item where one is independent component, you can convert into integral calculus. All straightforward. So into charge, voltage into charge. Charge is independent component and voltage is dependent upon the charge. This is algebra. Now, if it is voltage into charge is the net charge means how much charge it has stored. 0 to Q, that is the net charge or Q. If I say Q is 10, means 0 to 10. 10 is the amount of the charge right now. What is the voltage? Voltage is 10 volt, charge is 10, 100 joule of energy it has stored right now. Anyway, now this is a very ambient condition to place it to convert into integral calculus. Function over x into x is function over x into dx, and whatever the x amount is, now that will go in integral in limit x1 to x2 or 0 to x, whatever it is. Now, this is a good candidate to convert it into integral calculus. Now, what it will be? Voltage, that is function of charge, F, and braces Q, braces close. F function over charge into d of Q. So it will convert into function over Q into d of Q. Q is from 0 to any Q. This is charging circuit. Initially charge was nothing, 0. Now whatever the charge right now is. What is voltage? Voltage is 1 by C into Q. So it becomes 1 by C into Q dq from 0 to Q. You can say capital Q or whatever it is. 1 by C is a constant that will come out. Q into dq. It will become Q square by 2. Now, if people are novice, then immediately they will say, okay, the power is voltage into current, voltage into Q by T. Voltage is 1 by C into Q. 1 by C Q square is the energy that is stored. That is not, that's where calculus comes into the picture. When you multiply two items, one item is independent variable and one is dependent upon that variable, this multiplication will not be straightforward. 1 by C Q into Q is not 1 by C Q square. 1 by C Q into Q is 1 by C Q square by 2. Okay, that is where integral calculus comes into the picture. Okay, you had Q by C, voltage is Q by C, then I can make dq by dc, not required. Because C is constant. If I go for division and numerator is algebra, Denominator is algebra. Numerator is dependent upon denominator. Then if it was C by Q, then I would have taken dC by dQ. Okay, but if it is Q by C, where denominator is a constant, not required, then we'll convert into differential calculus. Now I can take 1 by C out, integration Q dQ, Q square by 2, 0 to Q means Q square by 2 into 1 by C. Makes sense? This is the, okay, how I can measure charge at any moment. I can measure voltage at any moment, no problem. You can convert it now. 1 by C Q square. Q square is CV square. Voltage equal to 1 by CQ. So Q equal to CV square. 1 by C square, V square. It will come as CV square. So CV square by 2 is the energy at any moment that is stored in capacitor. Okay, I have not seen the book or anywhere. I believe it is all right. This is how it should be. What is the energy stored in capacitor any moment is the half CV square, not C square V square, half C V square, or 1, 1 by C into Q square by 2. That is also energy stored at any moment. I believe it is all right. Okay, now what would be Q at any moment? If I say 1 by 2 into 1 by C Q square, the Q in any RC circuit is, I believe, Q into e to the power minus t. I'm sorry, Q z. It will be charge at any moment. I don't remember actually. Charge at any, okay, leave. Charge at any moment is, I believe it is 1 mile. I don't remember. Okay, voltage. What is voltage at any moment? If it is half CV square, half CV square, then voltage at any moment is Vs. That is the voltage of the battery. So if it is charged through RC circuit, Vs, and in braces 1 minus e to the power minus t by RC. This is what I, e to the power minus t by RC. Okay, if t is growing, then e to the power minus t by RC will start moving towards 0. Then voltage across capacitor will be Vs, complete Vs. When t is 0, then e to the power minus t by RC will be 0. E to the power 0 means 1. 1 minus 1, 0. No voltage across the capacitor. So 1 by 2 C, and instead of V, I can say Vs 1 minus e to the power minus t by RC whole square. That is the energy at any moment. Now someone can change the time and see at any time how much is the energy that is stored. Okay, what is the power then? That energy by T. That energy is a function over time. Makes sense? Okay, 1 by 2 C, and in the V, CV square, 1 by 2 C V square, that is the energy when voltage is V. Now instead of V, make Vs, that is the battery voltage. Battery is connected to capacitor in series. This is battery and it is connected to capacitor and resistor duo. Capacitor and resistor are connected in series, and this is called load. This load is connected across battery, and then the current starts flowing and energy, the capacitor starts storing the energy. Now, in that sense, any moment when voltage across the capacitor starts growing, any moment voltage is V, where voltage will go maximum up to the battery voltage only. If any moment voltage is V, at that moment at that moment energy stored across the capacitor is half CV square, half CV square. Okay, in that sense, half C, and instead of V, I put Vs, that is the battery voltage, in braces 1 minus e to the power minus t, that is time, by RC. R is the resistance of this RC, that is around 330 ohm I have taken, and the capacitance, that is 330 microfarad, that is the capacitance I believe. Okay, So 1 by 2 C and in braces Vs braces 1 minus e to the power minus t by rc whole square. That will come as 1 by 2 c Vs whole square. Vs whole square and in bracket 1 minus e to the power minus t by rc whole square. Okay, whatever it will come. This by dt, that is the power, that is power, that is power, the power this capacitor is receiving from the battery any moment. So initially this power will be, initially this, I don't know, whatever it is, initially voltage will be less, whatever someone can calculate, 1 by 2 c Vs square. This is full constant. So it will come out d of 1 minus e to the power minus t by rc whole square by dt. If someone differentiate it, it becomes 2, 2 and then 1 minus e to the power minus t by rc. And then differentiation of 1 minus e to the power t by rc. 1 will go away and minus will be there, e to the power minus t by rc, differentiating with with minus t by rc, it will remain like that only, minus e to the power minus t by rc. Now differentiating minus t by rc with dt, it will give minus 1 by rc, minus minus gone. Okay, it will become 1 by 2 c Vs square and then 1 by rc, 1 by rc into 2, 2, 2 gone, and then 1 minus e to the power minus t by rc only. That will be power. If that is the case at the when time is 0, when time is 0, then it will become 0. No power is consumed by the capacitor. No power the capacitor is receiving when time equal to 0. But as time is growing, e to the power minus t by rc will start tends to 0. In that sense, it will start absorbing the power. Generally, voltage, so it will follow the voltage curve. This is what we are saying. It will be C Vs whole square, C Vs whole square into 1 by Rc. Cc gone. Okay, Cc gone. It is now Vs square by R. Vs square by R and in braces 1 minus e to the power minus t by Rc. This is what I think so. Okay, in that sense, now it is following the voltage curve only. Voltage curve is exponential curve. Means at the beginning, the voltage that this capacitor will show the voltage curve of this capacitor. If I draw the time, if this is the time and this is the voltage across the capacitor, then beginning it will show sharp rise in the voltage. Then it will start becoming flat line. This is typically called exponential curve. So exponential curve e to the power minus exponential. It is not exact exponential. 1 by exponential, I believe. So it is e to the power minus t by r. I don't know, whatever it is. Okay, I have not seen it anyway. So this is how typically voltage curve we see. Means at the beginning voltage will go like this, and then slowly it will become stagnant. And after some time, then when it becomes voltage becomes the battery voltage, it will be completely flat. There is no change seen in the voltage. Looks like power is going like that only. Okay, that is the idea. Whereas current at the beginning, current will be maximum. At the beginning, current will be maximum. So current is I0, that is the beginning current, e to the power, I believe, minus t by RC. So at the beginning, when t is 0, current will be maximum. So current will follow this kind of voltage, will follow this kind of curve, and current will follow this kind of curve. Looks like the power will also follow the what voltage is following. This is what I am thinking so. Anyway, this is the story of calculating the energy and power any moment. Okay, voltage equal to Vs 1 minus e to the power minus t by Rc, that we have discussed many times in the past. It can be searched in our video, that capacitor voltage or something like that, and someone can find how to calculate voltage any moment. That falls in differential calculus, that we will talk later. that there is some one more part in calculus called differential calculus. What energy we have calculated right now, it does not fall in differential calculus. So it is pure integral calculus that we are seeing. Okay, okay, can we go for the differential calculus and here there that we will see. Right now, that is not the concept that we are pursuing. Anyway, so I believe this is the I actually the idea was to talk about the area vector. We started with the length vector, area vector, volume. But I thought that the real life scenario, person should understand just going through the volume of sphere, volume of this, area of this, length of this. It was like a monotonous. So person should really understand that in real life, we can calculate anything that looks like mathematics. Energy across capacitor is 1 by C Q into Q. That is 1 by C Q square. At the beginning, it looks like this. But when we proceed in mathematical step by step, then we start feeling that it is multiplication of 1 by C into Q with Q, where 1 by C into Q is separate and another Q is separate. It is multiplication of these two items, where right hand side Q is an independent variable, where this side, that is voltage, that is 1 by CQ, is dependent upon them. And it converted into 1 by CQ dq and Q square by 2. Q square by 2. So it is half, I believe it is half CV square. This is what, or half, half Q square by C. Whatever comes to someone's mind, easy for them. Mind blowing, amazing. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. How nice it is to get the actual formula when we start with the pseudo mathematical formula, and step by step we land up into calculus and finally we solve it. Amazing, mind blowing.